Deep inside a Sacramento evidence freezer, a microscopic string of biological code sat frozen in time for over 40 years. It was a genetic signature left behind by a phantom, preserved on faded cotton swabs and glass slides from decades-old crime scenes. This microscopic evidence held the complete identity of the most prolific serial predator in California history. Yet, for nearly half a century, it was utterly useless. The biological material was a locked door, and law enforcement simply did not possess the key. The crimes were staggering in their sheer volume and meticulous execution. Between 1974 and 1986, a masked intruder terrorized neighborhoods across the state, committing over 50 sexual assaults and at least 13 murders. He stalked his victims, learned their routines, and struck with military precision. He left no fingerprints, no dropped wallets, no careless clues. He left only his DNA. But in an era before genetic profiling, that biological material was merely a silent witness, waiting for science to catch up. When forensic DNA analysis finally emerged in the late 1980s and 90s, investigators believed they had their silver bullet. They extracted the killer's genetic profile and ran it through every available system. They waited for a hit. They waited for a name. But the screens remained blank. The phantom was not in the system. He had never been arrested for a felony that required a DNA swab, meaning his genetic fingerprint existed in a vacuum, entirely disconnected from a known identity. Analyzing the limitation of the combined DNA index system reveals exactly why the trail went cold. Traditional database matching relies on short tandem repeats, specific markers that are highly effective at confirming a direct, one-to-one match with a known offender. However, the national system is remarkably narrow in its scope. It can sometimes identify a parent, a child, or a full sibling, but it is practically blind to anything beyond the immediate nuclear family. If the killer and his closest relatives avoided felony convictions, the traditional database was a dead end. This limitation forced a radical shift in investigative strategy. Detectives realized they could no longer sit back and wait for the killer to make a mistake and get arrested. They had to proactively hunt him through his own bloodline. The answer would not come from a centralized government database of convicted felons, but from the rapidly expanding world of consumer DNA testing, where millions of ordinary people were voluntarily mapping their ancestry. The forensic breakthrough required an entirely new kind of biological translation. Crime scene DNA, historically processed for those short tandem repeats used by law enforcement, had to be reformatted. Investigators needed to extract single nucleotide polymorphisms, the dense, data-rich genetic markers used by commercial ancestry companies to determine heritage and find distant cousins. It was a monumental laboratory challenge, requiring scientists to extract a comprehensive genetic profile from severely degraded, decades-old evidence, while strictly maintaining the chain of custody. Once they had this new, highly detailed genetic profile, investigators needed a place to search. They could not simply serve a warrant to major commercial DNA companies, as those databases were walled off by strict privacy policies. Instead, they turned to a public platform called GED Match. GED Match was not a testing laboratory. It was an open-source repository, a digital hub where genealogy enthusiasts voluntarily uploaded their raw DNA files to find lost relatives and build out their family histories. Uploading a notorious serial killer's DNA to a public genealogy website was an unprecedented maneuver. It was a leap into uncharted territory, operating in a novel space where the boundaries of digital privacy, public data, and criminal investigations intersected. When investigators finally hit the upload button, they were not looking for the killer himself. They knew he had not uploaded his own DNA. They were looking for the genetic echoes of his extended family. The GED Match algorithm churned through hundreds of thousands of files, comparing the killer's genetic sequence against the public uploads. When the results populated, there was no direct match, no sibling, no first cousin. The closest hits were third and fourth cousins. In the realm of genetic genealogy, a third cousin shares a set of great-great-grandparents. This meant the common ancestor between the killer and his closest genetic match lived sometime in the early 19th century. This is where the laboratory science ended and the grueling, historical detective work began. Investigators were faced with a staggering task. They had to identify those great-great-grandparents from the 1800s and then trace every single one of their descendants forward through time to the present day. They were no longer just looking for a suspect. They were engaged in the most complex genealogical tree building ever attempted in a criminal case. Building this tree required an obsessive dive into public records. Investigators scoured census data, birth certificates, marriage licenses, obituaries, and newspaper archives. They mapped out generations of families, documenting the sprawling, complicated webs of human reproduction. Every marriage, every child, every divorce had to be verified and slotted into the massive diagram. It was an exercise in extreme patience, tracing thousands of individuals across multiple states and centuries. As the family tree expanded, it grew to encompass thousands of people. The killer was somewhere on this sprawling schematic, hiding among distant relatives who had no idea they shared a bloodline with a monster. To find him, investigators had to begin pruning the branches. They applied the known parameters of the Golden State Killer to the thousands of names on their list, systematically eliminating anyone who could not possibly be the suspect. The first filter was gender. The killer was male, so half the tree was immediately disregarded. The second filter was age. Witness descriptions and the timeline of the crimes dictated that the suspect had to be born between 1940 and 1960. Any male descendant born outside that window was crossed off the list. The sprawling canopy of the family tree was beginning to narrow, but thousands of potential leads still remained. Next came the geographical filter. The crimes occurred in very specific areas of California during the 1970s and 80s. Investigators cross-referenced the remaining male descendants with property deeds, voter registrations, and employment records. Men who were living in New York, Texas, or overseas during the crime spree were eliminated. The suspect pool shrank from thousands down to hundreds, and then down to dozens. At this stage, the investigation required a seamless fusion of ancestral research and traditional detective work. Investigators began looking for red flags among the remaining men. They looked for criminal records, ties to the specific neighborhoods where the attacks occurred, and physical descriptions that matched the composite sketches. The tension in the task force was palpable. They were closing in on a ghost who had evaded capture for over 40 years. The genealogical branches finally narrowed down to a single, distinct family line. Within this specific branch, the focus locked onto two brothers. One of the brothers was quickly eliminated through a familial DNA test obtained from a close relative, which definitively proved his genetic line did not carry the killer's markers. That left only one man standing at the end of the long, complex trail of DNA and historical records. His name was Joseph James DeAngelo. He was a 72-year-old man living a quiet, unassuming life in a Sacramento suburb, right in the heart of the area where the East Area rapist had launched his reign of terror. When investigators pulled his background file, the pieces of the puzzle slammed into place with terrifying precision. The profile fit so perfectly, it sent a chill through the task force. Joseph James DeAngelo was not just a California resident of the right age and physical description. He was a former police officer. He had served in 2 different California police departments during the exact years the crimes were being committed. This chilling revelation explained everything. It explained why the killer was so adept at avoiding capture, why he understood police response times, and why he left no traditional evidence behind. He knew the playbook because he was one of the people writing it. Despite the overwhelming circumstantial evidence and the genealogical link, the investigators knew they could not make an arrest based on a GED match family tree alone. Genetic genealogy is an investigative lead, a compass pointing in the right direction, but it is not a substitute for a direct forensic match. To secure a warrant and ensure a conviction, they needed DeAngelo's actual DNA to compare directly against the crime scene evidence stored in the freezer. They could not simply knock on his door and ask for a swab. Doing so would tip him off, risking the destruction of evidence or worse. Instead, law enforcement mounted a highly classified, round-the-clock surveillance operation. They watched his suburban home, tracking his movements as he ran errands, mowed his lawn, and lived his seemingly ordinary life. They were waiting for him to discard an item containing his biological material in the public domain. The legal doctrine of abandoned property dictates that once an individual throws something away in a public space, they relinquish their expectation of privacy. Investigators followed DeAngelo to a local store and watched as he touched the door handle of his car. When he walked away, a forensic technician quickly swabbed the handle. It was a start, but the sample was mixed and degraded by the environment. They needed something better. Days later, the surveillance team caught their break. DeAngelo discarded a piece of crumpled tissue in a trash can outside his home. Investigators swooped in, securing the discarded item with meticulous attention to the chain of custody. The tissue was immediately rushed to the state crime laboratory. The forensic scientists extracted the DNA and prepared to run the final, definitive comparison against the 40-year-old evidence. The laboratory results confirmed what the sprawling family tree had already suggested. The DNA from the discarded tissue was a perfect one-to-one match with the biological evidence left at the crime scenes. The mathematical probability of the DNA belonging to anyone other than Joseph James DeAngelo was billions to one. The phantom finally had a face, a name, and a verified genetic signature. In April of 2018, law enforcement officers descended on the quiet suburban street. They moved swiftly, executing the 2018 arrest of Joseph James DeAngelo outside his home before he even had a chance to react. The man who had terrorized California for decades, who had operated with absolute impunity, was finally in handcuffs. The shockwaves of the arrest reverberated not just through the local community, but across the entire globe. The resolution of the Golden State Killer case was an unprecedented triumph of modern science and relentless investigative determination. It proved that the answers to our most unsolvable mysteries might be hiding in plain sight, encoded in the genetic blueprints of ordinary citizens. By uploading a single crime scene profile to a public database, investigators bypassed decades of dead ends and dismantled a wall of anonymity that was once thought impenetrable. This victory fundamentally altered the landscape of law enforcement. It validated genetic genealogy as one of the most powerful tools ever introduced to criminal investigations. Cold case units around the world immediately began dusting off forgotten files, realizing that thousands of unidentified suspects could now be tracked down through the public genetic data of their distant cousins. The methodology pioneered in California became the new gold standard for solving the unsolvable. However, the methodology also sparked a fierce, ongoing debate about privacy, consent, and the ethical boundaries of utilizing consumer data for law enforcement purposes. The fact that an individual could inadvertently implicate a distant relative simply by exploring their ancestry raised profound legal questions. It forced a societal reckoning, balancing the urgent need to capture violent predators against the fundamental right to genetic privacy. Ultimately, the legacy of the GED match breakthrough is etched permanently into the history of forensic science. It stands as a testament to the power of innovation, proving that when traditional methods fail, a shift in perspective can illuminate the darkest corners of the past. The capture of the Golden State Killer ensured that no predator, no matter how much time has passed or how carefully they hide, can ever truly outrun their own bloodline.